Good evening, guys. Today I'm going to show you how to make a DC motor speed controller using PIC and motor driver. Okay, let's start talking about the components. Well, the components I'm using here is a PIC 18F2550. This PIC has 28 pins. 2 of these pins are pulse width modulation channels. The others are digital output or analog inputs. I have used 2 of these pins as analog inputs to get a variable width for the pulse width modulation. Okay. The potentiometers create a signal between 0 to 5 volts. I have converted this volt signal to a byte signal, which is from 0 to 255, which is 256 levels of width modulation. Okay. Now let's talk about the driver I'm using. Alright, here's the circuit. This is the driver I'm using, which is L298N. It's a common inductive load driver. And here's the PIC I'm using, which is already mentioned. Here are 2 potentiometers. Alright. This analog signal is sent to the microcontroller and it's converted from volts to bytes inside the microcontroller, and then it's sent to the pulse width modulation, and the pulse width modulation goes to trigger the driver so it can run the motor. Okay, let me explain for you how did I connect the circuit. First of all, I'm going to start from the input signal, as it's the sequence. It starts from the input, goes to the processing, and then goes to the output. So we're going to start explaining this part. Well, here is the potentiometer. It's a variable resistor, and a variable resistor. Okay, one of the terminals is connected to VCC, which is 5 volts, and the other is connected to the ground, which is 0 volts. Okay. When we turn this multi-turn potentiometer, it sends us an output between 0 to 5 volt. 0 volt to 5 volt. This signal goes to the PIC. Here's the PIC. Okay. This signal will go directly to the PIC. Inside the PIC, in the program, we convert the 0 to 5 volt to 0 to 255 bits. Okay, so we can get more stages of pulse width. Okay, inside the PIC, the analog signal will be converted, as we explained, to a byte, which is 255 bits, and then it's sent to the pulse width modulation output. It's converted here, and then it's sent to the pulse width modulated output. Okay, modulation output. Well, here are the pulse width modulation channels which are connected to the driver. Okay, now let's start explaining the program. Let's talk about the program. First of all, we need to open a new project by the flow code. Let's start the flow code. Okay, let's choose create a new flow code flowchart, and we'll choose the microcontroller type, as we mentioned before. This is the number that we mentioned before. Okay, here is the chip. So you know that the pulse width modulation is a CCP in the microcontroller. So CCP2 is this pin and CCP1 is this pin. Okay. We need to make a few configuration for the chip before we start. Okay. We go to the build project option and we'll choose the speed of the clock that we're using. Okay, check configuration. The most important thing that we need to turn the watchdog timer off, and we choose 8 megahertz input because this is my oscillator. Okay, now let's start the program. So we are going to use 2 pulse width modulation. We get the pulse width modulation from here. This is number 1 and this is number 2. Okay, sorry. So the first one, CCP1, is connected to channel 1 and CCP2, we change the name, CCP2 is connected to channel 2. Okay. We also need the 2 potentiometers. For the 2 inputs. Okay, connection. First one connected to analog 0. Second one is connected to analog 1. Okay, let's make a loop so it can repeat itself, and we'll need an input for reading the analogs. Pulse width modulation 0. We'll choose analog 0. Okay, read as byte. We are going to read the analog signal that comes from the output of the microcontroller. Add a new. Okay, we're going to name this as analog 1 or P1. Refers to potentiometer 1. The initial value is 0. The type is byte, which is from 0 to 255 as we mentioned. I'll need to make another variable which is P2, potentiometer 2. The initial value is 0. Also the type is byte. Okay, we're going to use another input or just like this. Okay, so it will read the analog as byte and send it to the variable P1. Okay, it will read the analog 1, the other analog I mean, and send it to P2. Okay, now we need to enable the output for the pulse width modulation. Pulse width modulation 0, enable. Pulse width modulation 1, enable. Okay. Let's reduce this a little bit so we can have more space. Okay, and now we're going to send the width of the signal. Okay, so we have enabled both of the channels and now we need to send the width of them. we go to the set duty cycle. We choose the duty cycle we want, which is P1. And here we're going to choose duty cycle set duty cycle versus P2. Okay. Now when we run the program, it shows that the period is 0 duty cycle because the potentiometer is turned to a 0 value. So when we turn this, the pulse is going to be wider, as you see. Alright. Okay, let's start the program. Here, if we click here, it will compile to a hexa file, so we can write it to the microcontroller. And now, after we've done the circuit and we've done the program, it's time to run the circuit. Okay. As you guys have seen, I have connected a motor, a DC motor, to the circuit. It's a 12 volt DC motor. Now I have made a little circuit for isolating the microcontroller from the 12 volt. I used an optocoupler oscillator. Okay, and I made these two inputs as the direction for the motor. Now when we trigger one of these directions, so the motor starts running. Let's control one of the, as you guys can see, it started to slow down. There you go. I'm turning that down. Okay. Alright. This is the reverse direction. Okay. I'm going to turn that down too. So it's going down, down. If we want to go up, so now it's going up, as you can hear the sound of the motor. So it's now turning up. Make it faster and faster. Okay, so now the circuit is working. I hope you guys enjoyed that video tutorial. This video was made by engineer Ghazwan. Thanks.